Hello friends, I welcome you all in this session. In previous session we discussed probability issues in network models and we have seen couple of examples. In this session we will be looking at simulation of networks. Though we have studied simulation when we were studying about management of standalone risk of projects, there we have seen how to use simulation analysis to find out NPV of a project, and we did use random numbers in that topic. So, we will be using random numbers to simulate the duration of the activity. Now, let's get started with this particular topic, simulation of networks. We have seen that an activity can be either deterministic, it can take a beta distribution shape, it means it can have 3 time estimates, it can be a normally distributed activity with mean and standard deviation, it can have only 2 time estimates, for example TO and TP, optimistic time and pessimistic time. But suppose if there is an activity which is taking time in uncertain manner. When I say uncertain manner, it means sometimes it takes let us say 2 days, sometimes it takes 20 days, sometimes it takes 5 days and so on. So, it is quite random. It's very difficult to predict the nature of that particular activity's duration. So, since the situation is uncertain, we will use simulation methodology for solving a problem of uncertain time of an event, right. So, let us look at a project wherein the chance that an activity 1-2 will take 5 days is 20%. It will be completed in 6 days, its probability is 30%, 7 days 30%, 8 days 20%. Now, let activity 1-2 be the random variable which denotes the duration of activity 1-2. Now, the duration of the activity 1-2 would be determined by a random, let's take this as a random variable, the duration is random variable. The probability distribution of T12 is shown in this. So, this is probability distribution of activity 1-2. Similarly, the probability distribution of activity 4-5, 1-3, 2-4, 3-5, 5-6, 2-6 and 4-6. Now, we have to use this information plus use of random numbers, we will find out duration of this project. Now, let us generate a random sample for Tij activity T, its duration is Ij, right. Let Fij denotes the cumulative distribution function of Tij, that is Fij x is equal to probability that Tij is less than or equal to x. So, if you look at this activity 1-2 for which probabilities are given, we can write this equation like this. So, F12x is equal to 0, x is less than 5. So, x is between 5 and 6, probability is 0.2, then 0.5, 0.8 and 1. Now, this is equation 1. Now, we can rewrite this equation as this. So, let u be the random variable which is distributed uniformly over 0 and 1, right. Since Fij x is uniformly distributed over 0, 1, it can be proved that equation 1 implies this. So, random variable u is in between, it is, if it is the probability that the activity Tij, whatever is ij, whether it is 1, 2 or 4, 5, whatever is that activity, that activity will take 5 days if u value is equal to or greater than 0 and less than 0.2, right. Then less than or equal to 0.2 but less than 0.5, then the duration would be 6, similarly 7 and 8, right. How did we get this 0.2, 0.5, 0.8? So, for activity 1, 2, so 0.2, 0.5, 0.8 and 1, that is how we get, right. So, let us look at how to find out duration of activity 1, 2 given some random numbers, right. So, we are talking about activity 1, 2, right. So, activity 1, 2. So, we will say that we have the probabilities of this particular activity, and the probabilities are given in tabular form. It is like this. So, the probability is 0.2 and its duration is 5 days, right. Duration is 6 days, 7 days, 8 days, this is 0.3, this is 0.3 and this is 0.2, right. So, we can write on the duration of this activity using random numbers, right. So, we will say that this activity will take if your random number is in between this probability, then its duration is 5. So, this is u, right. So, 0.2 greater than less than or equal to u point less than 5. So, this 0.2 plus 0.3, so this is 0.5. 0.5 less than or equal to u less than 0.8, isn't it? 0.5 plus 0.3, 8, right. And finally 0.8 u less than equal to 1, right. So, this is 6, this is 7 and this is 8. So, for this particular activity we have been given certain random numbers, right, and using random numbers we will find out duration of this activity 1, 2, right. So, random numbers are what is there. So, 0.07, so let us say 0.07, then 0.01, 0.01, then 0.85, 0.24, 0.44, 0.72, 0.16, 0.11, 0.79, 0.18, 0.13, 0.62, 0.32, 0.74, then you have got 0.20, 0.96, 0.03, again 0.96, 0.82 and 0.82 once again, right. So, these are random numbers. Now, we want to find out duration of this particular activity. Now, this random number is 0.07. 0.07 falls in which range here? It falls here, right. It is between 0 and less than 0.2, right. So the duration of activity 1, 2 would be 5. 0.01, which range, in which range this 0.01 is falling? Again here, so duration is 5. 0.85, 0.85 is here in this range, right? So duration is 8. 0.24, 0.24 is here, right? 6. 0.44, 0.44 is here, right? So less than 0.5 is 0.44, so this is 6. 0.72, 7. 0.16 is 5, right? Right. 0.11, what would be the duration? 0.11, 5. 0.79, 7. 0.18, 5. 0.13, 5. 0.62, 0.62 is here, right? 7. 0.32 is here, 6. 0.74, 0.74, 7. 0.20, yeah, so this is less than 0.20, right? For equal to 0.20, this is 6. 0.96, of course 8. 0.03, 5. 0.968, 0.82, 8. 0.82, 8, right? So these are different durations of activity 1, 2 from these random numbers. Now you have to calculate these time estimates for all other activities which have been given in this question, right? So all these, for all other activities you need to find out what these different time estimates, and we have done this for 20 times, right? 1 to 20. So we are simulating the durations of all these activities 20 times, right? So this is for activity 1, 2. You can see all these values are here, right? Now you have to do it for all other activities. This is for activity 1, 2. Now just see this table, quite a complicated table. So serial number 1 to 20, random number for activity 1, 2 is 0.07, and this is the duration, right? So all these are durations of activity 1, 2. Now you have got different random numbers for activity 1, 3. Now this is 0.54, 0.4. In fact, you will have to again change these ranges according to the probabilities of activity 1, 3, right? So these are different random numbers, these are different durations for activity 1, 3. Random numbers and durations for activity 2, 4. Random numbers activity 3, 5, activity 2, 6, 4, 5, 4, 6 and 5, 6. So what we have done, we have generated time durations for these activities using random numbers, and we were already having their probabilities with us, right? Now you need to find out what is the duration of this project 1, 2, 3, 4, 5 and 6. So this is a project. We want to find out duration of this project using these random numbers. So the first is this, first serial number is this, right? And the duration for activity 1, 2 is 5, for activity 5, 6 it is 7, right? So let us find out what is the duration of this network. So we have got a network, and we will find out its duration, right? So network is this 1, 2, 3, 4, this is 6 and this is 5. This is 5. Now, if you look at this question, then for few activities, yeah, so in fact there is no deterministic time for even any of the activities. Okay, so for activity 1 2, what is the time? For activity 1 2, time is 5, right? So just write down 5 here. For activity 1 3, you have got 14, right? The duration is 14. For activity 2 4, duration is 27, right? So let me write all these durations. For activity 1 2, 1 3, it is 14. For activity 2 4, it is 7, right? It's there in table also. For activity 3 5, it is 5. For activity 2 6, it is 9. For activity 4 5, it is 6. And for activity 4 6, it is 14. 4 6, yeah, this is also there. 4 6 14, and finally 5 to 6, it is 7. So these are the durations of these activities for first run, first simulation run. Let us find out what is the total duration of this project. So let's look at this. T is equal to 0, T is equal to 5, T is equal to 14, right? T at this point is 5 plus 7, 12, right? 14 plus 5 is 19, right? And from here it would be 18, right? So this 19 is correct. Now this is 12 plus 14, 26, and from here also 26, right? So the duration of this project is 26, right? Now you have to find out duration for all those remaining 19 runs. So you will have 20 times 20 different time estimates for this particular network, right? So let us look at what are those values. So in this particular network which I have drawn here, there are two critical paths, right? So first is 1 2 4 6, 1 2 4 6, 1 2 4 and 6, right? And this second one is this 1 3 5 6, right? And the duration of this network is 26. So now you have to find out duration of this network for all other runs, right? For first run duration is 26, for second, third, and for other runs you need to calculate total duration of project, right? So let us look at what are those values. So for first run we have seen that the time duration is 26, right? And what are critical activities in first run? So if an activity is critical, just mark it as 1, right? So for 1 2 it is critical, 1 3 is critical, 2 4 is critical, 3 5 is critical, 2 6 is not critical. Just see, 2 to 6 is not a critical activity, 4 5 is also not a critical activity, 4 6 is critical, 5 6 is critical, and the total duration is 26. When you do it second time, its duration would be 27. When you do it 19th time, the duration would be 33, 20th time duration would be 30, right, and these are different critical activities in 20th run, right. So, 1 2, 2 4, 4 5, 4 6 and 5 6. Now, you just take the average of all these time estimates and average is 29.3. So, what is your conclusion? You will say that the duration of this project is 29.3, right. And if you look at there is something called critical index. So, if you repeat this project, let us say for 100 times, or if you take up this project for 100 times, then 75% of the time activity 5 6 will be critical. So, that is the meaning of critical index. So, in this particular project, most of the times the critical activity would be 5 6, after that activity 1 2 would be critical, 1 2 and 2 4, same value 65% and 65%, and then this one, right. So, in this way you should calculate the duration of the project. Now, what is the probability that the project will take 26 days? What is the probability? If you look at this table, then out of 20 times, 26 is the total time. How many times? 1, right, then 2 times, right. So, this is 2 by 20. How many times total duration was 7, so was 27, just once, right. So, this is 1 by 20. How many times it is? 28, just check here, 28, this second time, third time and fourth time. So, 4 by 20, and similarly there is you did not get 32 as the total duration even a single time, right, and 33 days just one time. So, probability that project will take more than 29 days. If I ask you a question, what is the probability that this project will take more than 29 days? For more than 29 days means 30, 31, 32, 33. So, just add this 5 by 20 plus 3 by 20 plus 1 by 20. So, you will get 9 by 20. If I ask you question, what is the probability that the project will take less than 29 days? Less than 29 days. So, what it would be? It would be 2 plus 1 3 plus 4 7 by 20, right. So, in this way you can simulate duration of an activity, right. So, since you have got computers these days, you can simulate it for let us say 20,000 times. So, you will get a precise time for an activity, right. So, the more the number of runs, better the duration of activity, right. Okay. Let us take this example, very interesting example, and we have to we have been given these 5 activities 1 2, 1 3, 2 3, 2 4 and 3 4, right. The duration of the activity 1 2 is constant, it is 5, right. So, there is no variance, right. Activity 1 3, its duration is 2, right, but activity 2 3, 2 4 and 3 4. So, the probability that activity 2 3 would be completed in 3 days is 0.3. It would be completed in 5 days, the probability is 0.3. It would be completed in 4 days, probability is 0.4. Similarly, for activity 2 4 and 3 4. Now, these are different random numbers given for activity 2 3. Similarly, for activity 2 4, for activity 3, 4, right. Now you have to simulate the network for 5 times and find out what is the distribution of its time duration. Find out its expected time, how much time this project will take in when you do it for 5 times. What is the probability that the project will be completed in less than 14 days, and find out critical indexes of all the activities. We will take up this example and we will solve it, right. So, let us first draw this network 1, 2, 3 and 4, right, very simple network. So, this is 2 to 3. Activity 1, 2 has got constant duration, right. 1, 3 has also got constant duration, but for activity 2, 3, if you look at activity 2, 3, T2, 3, right, the duration for activity 2, 3, you have been given probabilities, right. So, we will follow the same method which we did in previous example. So, u is between 0 and less than 0.3, right, is less than or equal to, u is in between 0 and equal to 0 and more than 0, but less than 0.3, right. The duration is 3 days, right, 3 days, 3 days, right. It is between but less than 0.7. We have added 0.3 and 0.4. So, u is equal to and less than 0.3 but less than 0.7. What would be the duration? Duration is 4, right, less than or equal to 0.7 but less than 1 is 1, right. So, 0.7 plus 0.3 is equal to 1 and the duration is 5 days, right. The random numbers are first time for activity 2, 3, right. So, 0.2, 0.1, 0.9, 0.3 and 0.2, right. Right. This is for activity 2, 3. Now, for activity 2, 4. For 2, 4 also you have been given probabilities. So, 0 to 0.3 and the duration would be 6 days. Then 0.8, 1, this is 0.3, 0.8, this is u and this is u, right. So, duration is 6, 7 and 8 and the random numbers are 0.9, 0.0, you let it be 0, right, let it be 0, then 0.1, 0.5, 0.6. This for activity 2, 4. For activity 3, 4, activity 3, 4, 0 is 0.2 and the duration is 3 days, 0.9, this 0.2, 0.9, 1, and the duration is 4 and 5, right, and the random numbers are 0.6, 0.2, 0.9, 0.1 and 0.1. And we have also been given time durations of 1, 2, and so for activity 1, 2, for activity 1, 2 and for activity 1, 3. For this the time is 5 and 2. So let me write these things over here. Days are in this column. These are random numbers. Now we have to when we for the time being, let me stop here, and the solution to this question we will see in next session. So I hope you would have understood how to find out time duration of an activity which is quite uncertain using random numbers. Thank you very much.